NMR. So where do you go for NMR? Double bonds are from 4 to 8. And regular double bonds from 4 to 6. But 6 to 8 is the benzene. You go and you saw signals around 7 point whatever. So you know you have a benzene. Then you don't jump away from there. You say, there's a number written on top of it saying 3. What is that number? That's integration, right? So you have how many hydrogens on the ring? Only 3. How many should it be usually? 6. So it should be 6, but you have only 3. What does that mean? You have a 3 substituents. That reduction you forgot because you were jumping around. So with using this information, you have to say, oh, it may be the case with the 3 groups, but how are they oriented, right? So they are arranged either this way, this way, this way. There's no other way. I tried. Standing here, I tried. These are the only 3 ways. Then how do I know which one's which? You see, follow-up question, right? Natural flow of the idea. How do I check it? How do I check it? Well, hydrogens are next to each other, and the 2 of them together, none of them together. So that will influence the neighbors differently, right? So what is it then? What do you look for? Influence of the neighbors.
Signals.
Splitting. Splitting, right? If it's this case, everybody should be singlets. If this is the case, 2 doublets, because they are neighbors each other, right? Doublet, doublet, and this guy, singlet. And if this is the case, doublet, doublet, and triplet. Do you have triplet there?
Yes.
No. No triplet. Do you have all singlets?
No.
These are not. So it's this case. Then I say, okay, I used up 6 carbons and 3 hydrogens. What's remaining is 4 carbon, 11 hydrogen, oxygen. There is no more double bond, no more ring. It's a straight chain. Then, okay, OH. I find easily on IR. Also on NMR, I double check. And the CH3, you don't check it on IR, but you check it on NMR singlet with the 3 hydrogen. That's only CH3. The no hydrogen neighbor, right? Then there are 2 complicated signals left. 6 hydrogen at 1.3 ppm with a 2 tall, but some details splitting there. You cannot count. So that's when our lesson earlier matters. More than 2. Okay. Here you have 1 hydrogen at 3.2, but many lines. Okay. But you know each other already. How do I know? This guy with the many signals, influenced by who?
The neighbor.
This guy, methyl? No, methyl has no neighbors, right? So this guy. So how many?
6.
6. So this guy is influenced by 6, and that guy is influenced by how many? 1. So, that means I have CH with 6 hydrogens as a neighbor.
Okay.
And how many carbons I used up so far? 1, right? And then 2, 3, 4. I used up everything. Hydrogen, 6, 7, 7 and 9, 10, 11. Right? Used up everything. So these are all. I have OH, I have CH3 alone, and I have these 2 guys making up, these 2 complex guys making up one piece together. So 1, 2, 3. How can I arrange them? Well, many different ways. We don't know for detail, right? Which one's which. Well, for graduate students, you can do resonance and stuff and find out their detailed chemical shift and pinpoint exactly this, but that's not your subject. Don't worry. If you can come up with any of these, you're fine. So most difficult part was here. You're not making right step of reasoning. You are looking for some random piece of puzzle. Okay. So 3. What does that mean? Take time, calm down. 3 means 3 left. 3 missing. Oh, 3 missing. How are the chances?